why evolution built living tanks, and why it almost always took them apart again. For most of life's history on this planet, the single most important question a creature could answer was a simple one. How do you stop something from eating you? Speed worked, stealth worked, poison, camouflage, size, all of these worked. But one solution kept reappearing across hundreds of millions of years, in animals that shared almost nothing else in common: armor. It appeared in the first complex animals of the Cambrian seas, in ancient fish, in dinosaurs, in early mammals, each time in a completely different form, built by creatures with nothing else in common. And almost every time, after a period of extraordinary success, it vanished again. Today, a handful of armored animals still exist. A few species of pangolin, several types of armadillo, tortoises, crocodilians. They feel out of place in the modern world, slow, deliberate creatures that seem designed for a different era. To understand why they survived, when almost everything else did not, you have to go back to the worlds that first built armor, and to the rules it depends on to function. 400 million years ago, during the Devonian period, the oceans were dominated by a group of fish unlike anything alive today. They were called the placoderms, and they were wrapped in bone. Heavy plates fused across their heads and upper bodies, forming shields over their most vital anatomy. Some were small, flat-bodied creatures that skimmed the seafloor. Others were enormous. Dunkleosteus, one of the largest predators the oceans had ever produced, carried jaws capable of shearing through the armor of other placoderms. Its jaw plates were sharp-edged bone, generating bite forces among the greatest in vertebrate history. Armor in the Devonian was not just defensive, it was structural. The plates that covered a placoderm's head also anchored the muscles powering its bite, giving armored fish a mechanical advantage over softer competitors. In warm, stable, slow-moving oceans, this was a winning combination. For nearly 50 million years, the placoderms were among the most successful vertebrates on Earth. Then the world changed. Oceans cooled, currents shifted, and oxygen levels became unpredictable. In these new conditions, streamlined and faster fish began to emerge, capable of acceleration that heavily armored bodies could not match. The weight that had once been an advantage became a liability. But what ultimately ended the placoderms was not a predator. It was the planet itself. A series of environmental collapses during the late Devonian wiped out more than half of all marine life. The placoderms vanished entirely. The first great age of armor was over. Once ecosystems recovered, armor returned. By the Jurassic, forests had spread across the continents and dinosaurs had grown enormous. Plant eaters faced a specific problem: too large to hide, not always fast, enough to outrun what hunted them. Evolution's answer, in several lineages simultaneously, was armor. The stegosaurs carried rows of tall, bony plates, likely serving overlapping roles in display, temperature regulation, and defense. At the tail tip, bony spikes formed a weapon now called the thagomizer. An Allosaurus vertebra has been found with a puncture wound consistent with one of these spikes. Stegosaurs were neither fast nor agile, but in dense forest environments where encounters happened suddenly and at close range, armor gave them a way to survive. In the Cretaceous, the ankylosaurs took armor further than any land animal before or since. Bodies encased in interlocking plates, skulls reinforced into helmets, tails fused into solid bone clubs capable of fracturing the leg bones of large theropods. The Cretaceous offered nearly ideal conditions: warm temperatures, abundant plant life, and the resources to sustain a large, heavily built body. Armor did not just survive. Here, it flourished. And then, 66 million years ago, an asteroid impact collapsed ecosystems globally. Large, slow, heavily specialized animals were among the first to perish. Every armored giant disappeared. The golden age of armor ended for the second time. The world after the dinosaurs belonged to mammals: small, fast, warm-blooded, and light. For millions of years, speed and stealth were enough. But as ecosystems stabilized, some grew larger, and as they did, they entered what biologists call the danger zone. Large enough to attract predators, but not powerful enough to deter them. Too big to vanish into cover, too small to stand their ground. Research across modern species shows that animals in this middle weight range, especially in open habitats, consistently develop specialized defenses that substitute for speed or size. It was here that armor reappeared in mammals. The earliest armadillo relatives were small, burrowing animals with a flexible shell, foraging in open ground, exposed and vulnerable, exactly the kind of creature that benefits from carrying its protection. Over millions of years, their descendants grew. By the Pliocene, this lineage had produced glyptodonts, animals the size of a small car, covered in a solid dome of fused bone, sharing ecosystems with saber-toothed cats and giant bears. For hundreds of thousands of years, they turned slow movement and heavy armor into a winning strategy. They did not fail because armor stopped working. They disappeared, as the placoderms and ankylosaurs had before them when the world that sustained them collapsed. But the rules that created armor did not disappear with them. Looking across these lineages, fish, dinosaurs, mammals, the same conditions keep producing the same solution. The first is energy. Armor is expensive to build and costly to carry. It only becomes viable when food is abundant enough that an animal does not need to range widely or move quickly to feed. This is why armor almost never evolves in cold or resource-scarce environments. The second condition is body size. Armor consistently appears in animals occupying a vulnerable middle ground, large enough to be worth hunting, but without the speed or size to avoid or overpower attackers. In the Devonian, this threshold sat at one scale. In the age of dinosaurs, it shifted upward as the predators did too. The principle remained the same. The third condition is the nature of the threat. Armor is most effective against rapid, high-force attacks, a single lunge or decisive bite. If an armored animal can survive first contact and make that contact costly, most predators will disengage. But armor offers little against endurance hunters or pack strategies. When dominant predators shift toward those approaches, surviving the first hit stops being enough. These three conditions explain not just why armor appears, but why it vanishes. When food becomes scarce, when predators become fast and strategic, or when the body size advantage disappears, the cost exceeds the benefit. Evolution finds another solution. With that framework in place, the last armored animals stop looking like relics and start looking like a precise fit for conditions that still allow armor to work. Pangolins feed almost exclusively on ants and termites, prey requiring no pursuit, found in warm climates with year-round abundance. They spend much of their time with their faces in the soil, unaware of approaching threats until contact is unavoidable. When threatened, they curl into a ball and wait. Armadillos occupy a similar niche, insect feeders in warm, open habitats, burrowing often, exposed when foraging. Their plates are jointed and flexible, a compromise between protection and mobility. Tortoises have taken the extreme version of this, fusing their ribs and vertebrae into a dome of bone. They carry their shelter everywhere and need not go anywhere when threatened. Crocodilians are predators rather than prey, but they carry armor too, rows of bone embedded along their backs. Their strategy is stillness, floating in water that bears their weight for them. All of them live in warm parts of the world. All occupy that vulnerable middle-size range. They are not accidents. They are the precise intersection of the three conditions armor requires to remain viable. The obvious question is whether armor could return at scale, whether some future age might produce new armored giants as the Cretaceous once did. In principle, yes. The rules have not changed. If ecosystems stabilize, if the right animals occupy the right size range, and predation pressure takes the right form, armor will appear again. Evolution has rediscovered it independently multiple times. There is no reason to think the pattern has ended. The surviving armored animals are already telling us something valuable. The solutions evolution arrived at, interlocking plates, flexible joints, domed geometries, are ones engineers now study deliberately, applying principles refined over hundreds of millions of years to modern impact-resistant materials. The animals themselves, meanwhile, are disappearing. Pangolins are among the most trafficked wildlife on Earth. Tortoises face habitat loss. Several armadillo species are declining. If armor returns, it will be in a world very different from ours. Some quiet future era when the disruptions of our age have long since settled. In that world, a small animal will feel something approach in the darkness. It will not run, it will fold inward, lock its plates together, and wait. The armor will hold. It has held before.